Hi everyone. Today I want to share with you the answer for number 17. So for part A, we have a current and then we have a velocity going 30 degrees. So we want to find out the magnitude of the magnetic field force, the direction, both direction and the magnitude. So first step, we want to find the direction and magnitude of magnetic field created by the current, which we use right-hand rule. So you use your thumb and then you go to the direction of the current and then you curl your fingers, which goes to the direction of the magnetic field. So in this case, the magnetic field in this electron is going inward. So by using this equation, we can find out the magnitude of that, which is 200 something times 10 to the negative 7th Tesla. Second step, we using F equal to QVB sine theta. And then in this case, theta is the angle between V and B. So it is 90 degrees instead of 30. So this term cancel out. By plugging numbers, we figured out the magnitude of the force is 3.84 times 10 to the negative 18th Newton. So using right-hand rule again, we can find out that direction of the force is perpendicular to the velocity. So if this angle is 30, this angle must be 60. So direction is going to be negative 60 for the magnetic force.
Yo, we're doing part B.
Hello. Okay, the figure shows a loop of current. A proton is traveling so it passes through the center of the loop. At the location, its velocity is diverted into the page.
What is the direction of the magnetic force that a current loop exerts on the proton?
So using the right-hand rule, we're able to trace our hand along with the current shown in the diagram. Using this, we're able to see that the magnetic field is actually coming out of the page.
Mathematically, in order to get the force, we use QV cross B. However, in this case, the velocity and the magnetic field are in anti-parallel. Therefore, when they cross, the product is 0. So the force is 0.
Hi folks, we are going to be starting with part C. So to begin with, we are given that there is a current 1 going upwards, but we do not know the direction of the current going through wire I2. But we do know that at the point P, which is evenly distanced between the two, a distance A away from wire I1 and a distance away from wire I2, that the magnetic field is going to be 0 at that point. Now, because I1 has a current going upwards through it, we use the right-hand rule to show that because the current is going this way, when we wrap our fingers around, there will be a magnetic field going into the page because of current 1. Then, because we know that the overall current is 0, therefore must be a field coming out of the page because of current 2. So knowing this, we try to curl our hand around to see which direction would cause a field to come out of the page. And doing so, we see that the current must be going upwards. Now, knowing this, we then try to find out what the force of I1 upon I2 is and the force of I2 upon I1 is. So, because I1 is going upwards, has a current going upwards, and it has a field going into the page at I2, we then can use the right-hand rule to see that with the current going upwards and the field going into the page, there's going to be a force acting on wire I2 to the left. Then, looking from the other direction, we know that there is going to be a field coming out of the page because of wire I2. So when we check with the right-hand rule with that, we have the current going upwards, field coming out of the page, and therefore the force going to the right. So both of the wires attract each other, as can be seen here.